cover something called algorithms. And we won't just talk about algorithms, we'll talk about the pseudocodes. The pseudocodes as well. Now, let's first understand what are algorithms, right? And then we can transition to what is a pseudocode. Anyone has a hang of what is an algorithm? Quickly, yes or no? Nod your heads, yes, no. No? Algorithms are plain instructions for anything that you want to do. So for example, if you want to cook a pasta, right? How will you write it down in plain English, step by step way is what an algorithm is. So the best way could be step one, I say, choose a pasta. Step two, boil pasta, and that's my way of cooking. You can disagree. Boil pasta. Number three, choose a sauce. What sauce you want to cook your pasta in? White sauce, orange sauce, red sauce, whatever. And then you say, all right, choose the cheese that you want to sprinkle on top of your pasta. Then what? Put everything in a pan, put it in a pan, and then maybe cook it for 10 minutes. Serve hot. Finish. That's an algorithm. Algorithm is the very plain English view of solving any problem. We do it day in, day out, right? So that is nothing but algorithm. That's about it. Now, another way of, if this is real life, let's talk about adding two numbers. What an algorithm could be for adding two numbers. You say, choose first number, choose second number, add both, display result. Finish. That's algorithm again. Now, what is a pseudocode? So algorithm, we won't spend too much time on it. Algorithm is basic plain English instructions to solve any problem in the world. That's it. All right. Now, pseudocodes. What is a pseudocode? Now, our computers, laptops, computers, doesn't understand this. Our computers are programmed to understand this language, this English language. And you would have heard, in case any one of you have IT or in information technology background or any subjects that you've done, you might have done. So there are a range of programming languages that we have, like Java, COBOL, C, C++. So there are many languages, programming languages, where you can build program. For example, if I take adding a two number as something I want to program on my computer. So I would need a programming language to convert this algorithm into the syntax, as in how that programming language is written, and then fed into the computer and then run it. Now that's too difficult, and the way we write our programming languages is called syntax. So syntax is how you write a programming language. Now there are thousands and thousands of programming languages in the world, and every language has a different way of writing the same thing. So the challenge is, if I want to program my computer to add two numbers, first challenge is which programming language my computer understands or I'm trying to program it on. And then I learn the syntax of that programming language. I mean, I should know how that language is written. I mean, that language is basically written in order to understand its instructions. So that is another challenge. So you cannot learn thousands and thousands of different programming languages in order to program your computer. So there has to be a step before that, but then a step after, algorithms that should solve that problem. And that is called pseudocodes. So pseudocodes are slightly more technical than the plain English language, but still very user understandable and readable, so that anyone who is using any programming language in the world can understand that pseudocode structure and convert into any language in the world that they want to. So, for example, I'll take this off the board. The pseudocode way of writing, so I'm just taking the example of adding two numbers and displaying the result. So the pseudocode of this algorithm, from my perspective, would be, I say, okay, I say start, the beginning, and I say enter number 1, and then I say enter number 2, and then I say sum equals to number 1 plus number 2, and in the end I say print sum, and I say end. This is a pseudocode. That was the plain English, the algorithm. That is the pseudocode. Now once you have the pseudocode ready, then whatever language you want to convert this into, Java or a C or a C++ or whatever, you pick up these instructions, write how do you enter number 1 could be written in 10 different ways by 10 different languages. Then you can convert it into computer program and then you can load it into your computer. So our goal here is not to learn any computer language, but to understand the very basics or nitty-gritties of how pseudocodes are. What are the basic building blocks of pseudocodes? You know, what exactly are the elements that you can utilize to create a pseudocode? Does it make sense? Yeah, all good? All right. Shall I take this off the board?
Yeah.
Now there are different elements of a pseudocode. There are different blocks that we can use in pseudocodes to do multiple things. So first thing is conditions, handling conditions. So the first one is if then block. If then block. If then block tells me if there is a condition, then you follow something, follow instructions. And at the end you say finish my if, that means end if. Okay, so if condition, these are the words that you have to write every time. They are called the keywords. So if you're using if then block, you need to know, you need to write these. So for example, if I have two numbers to compare and I want to print the greater out of the two. So for example, so I can say input number A and I say input number B, variable, right? And then I use this if then block, and I say if A is greater than B, then I say print A is larger, right? And I say and if. So this is how you use it. You take the number input from the user. Let's say now if this is fed into the computer program, into the computer, so it will display, okay, input A, someone will enter a 10. Then the next number, the next pop-up on the computer will be enter B, so it's at 9. And then computer goes to the next statement and checks this condition. The user input is finished. So if A is greater than B, yes, it is. So if this condition is true, it goes inside the loop, inside the condition, and it says print A is larger. So on the screen, you will say print A is larger, and then end if. Right? That's how you use the if and then. Now, you could say, what if A is smaller than B? Then we use another condition called if then else. If then else. And then else is again follow some instructions, and I say and if. This is the if then else block. Now in this case, if I have to implement it, I will say if A is greater than B, let's say this time the user inputs two different values. It says is entered A as 8 and B is 10. Come to this condition, I say if A greater than B, no, false. It won't go to the next statement. It will try to find the else. That okay, this condition is false. What do I do now? So you need to write else and you say print B is larger, and you say and if. So now if you run this program, you say you put in any value, it will find its house. So if A is, let's say, 2 and B is 20, then on the if, it checks the condition. A greater than B, no, false. It won't go in, it go to the else. That means it's the false statement. And whatever is inside the false gets printed. And we get the. Make sense? Yep. Cool. Now let's say we are going to print the grades based on the marks. So let's say there is a table. I'm just hypothetically creating something. So let's say there's a table which says if marks, these are marks, and that's grade. And I say if your marks are 90 and above, 90 and above you get an A, 80 and above you get a B, 70 and above you get a C, or anything down you get a D. Let's say we need to program this. So what do? I use if the condition. So I say enter marks, enter marks. Now I'm writing the pseudocode, right? Yep, Tanisha, all good? Enter marks, and I say if my marks are greater than equal to 90, print A. then I don't say else. Else I say, because I've got multiple conditions now. I say else if marks are greater than 80, then, now there's a then here, print B. I've got a third condition now, and I say else if marks greater than 70, then print what? C. And in the end I say, now for my last condition, that means if you haven't met any of these conditions, the last condition is always else. Else print D. And I say end if. Now let's see how this program is running. Let's say you've entered marks as 50 on the computer screen. Now Ryan, what will happen? It goes to this condition and says if marks are greater than 90, is this condition true? No, marks are 50. It doesn't go here. It comes to the next condition. Now it checks marks greater than 80. Sorry, no, it doesn't print B. Go to the next else if. Marks greater than 70. False. Doesn't print C. The last statement else. That means if all of the top has failed, print D, and it's going to print D on the screen. Got it? Now, if any of these conditions become true, that corresponding grade is printed. So this condition is called the if then else if block. If then else if block. All right, make sense? Now the next thing that we are learning is called loops. And I think you've got just for loop and while loop in your course, so we'll just quickly cover that. Loop means just repeating stuff, right? So loop means you're just going around and round and round. So the first loop is called the for loop. Now for loop is used when we want to repeat a set of statements in a controlled way. We know how many repetitions do we need. So for example, if I say I want to print Tanisha's name 10 times on the screen, right? And I ask you to write a pseudocode. So one way to write a pseudocode is, or any name that the user wants to print is, let's say I say enter name, and I say print name, and I keep going 10 times. So what will happen is you'll enter name and say Tanisha, and it says print Tanisha, 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 Tanisha till the time you're in. You can keep going. Now let's say you want to print this 1,000 times. That means you need to enter this print statement 1,000 times. But there's a far better way of doing it. So we use something called loops. Now, how is a for loop statement executed? So I say for I from 1 to 10 print Marwa. And I say end for. So what will now happen is, the moment computer comes here, it says, all right, for loop. That means I need to repeat something that is going to be within my for loop. How many times I need to repeat? So what will he do? The computer goes here and say, okay, from 1 to 10, that means 10 times. Finds the difference here, say, okay, 10 times. And he stores that counter value in a variable called I. So the moment he comes here, it assigns I the first value behind the scene in the memory. It says I equals to 1. And then it checks, is the value of I equal to the final value of I? No, I is 1 at the moment. I needs to go till 10. So that means you still need, that means this is false, it goes inside. And it says print Marva, so it prints Marva on the screen. Comes here, it says end for, alright, for loop finished, goes up. Increments I by 1. The moment it goes up, it adds I another 1 automatically. Compares this current value with the value that has to go until 2, which is 10. Say, is the current value of I equal to the last value? No. Cool, go inside. Print Marva again. And if N4, go back. I equals to 3 now. Do the comparison again. Failed. Print Marva again. And let's say I was to print Marva's name 4 times. And then say, okay, go back. Increase I to 4. Okay, is it greater, not equal, greater than 4? No, 4 is equal to 4, not greater. Cool, come inside, print Marva again. End for, increase I. Go back up, check the last. Yes, 5 is greater than 4. Now, this condition, it won't enter into this loop. It'll straight away go to the next one. It'll just jump the loop out. And we printed the name 4 times. Rather than saying print Marva, print Marva, print Marva, and 1,000 times, let's say, I mean, if I were to say 1,000 here, this name will be printed 1,000 times. If this was not there, you would write 1,000 print statements. So that's the magic of for loop. Here, for, from, to, and end for, they are keywords. Whenever you are writing the pseudocode using for loops, this is how you write it. And variable every time, most of the time you can take I. When they created for loop, they created I as the variable, and that's how it has been associated. But then you can take any variable here, right? But then I is like more universally accepted variable with I, with for loop, right? But then no one really is. You can take an X, you can take an A, you can take a B, whatever, right? But then that's universally with for, the counter is I. That is why it says I. Make sense? All good? Cool. Now, I will take the same example, but obviously a different name this time, and we will try to print the name of a particular person, let's say 4 times, but then this time using a while loop. So while loop has a condition associated with it. Till the time that condition remains true, the instructions under while loop are executed. The moment that while loop condition is false, it comes out of that loop. So for example, I want to print again the name of a person, let's say X 4 times. So I say a word called counter, and I say counter, and you say you use an arrow, right? use an arrow. You don't use an equal to here, right? You use an arrow. Now, I say while condition is counter is less than 4, while the counter is less than 4, and I say print x, and then I say counter equals to counter plus 1, and then I say end while. Now you see the biggest difference between the for loop. If I write the same story with the for loop, I'll say for I 1 to 4 print x, and I say end 4. These two pseudocodes will exactly do the same thing. But what is the difference? In the for loop, you had a counter I here, which you were not incrementing yourself. It was auto-incrementing by 1 every time, right? We did not add anything to 1 to increase its value and then check the condition. While here, you need to take a variable. Let's say for the ease of it, I take I, just so that, let's say this is I. I have to define the I first, give its initial value to be 0, and then I get into the while construct. And I say while I is less than 4. So at the first place, when this piece of code is executed, you say I value is 0. The moment it hits this, it checks this value. Is I less than 4? Yes. What do I need to do? Go inside. Print x. It prints x. Now, with for loop, it was auto incrementing the value of I and going up. Here in while is a bit of a manual one. You need to increment it yourself. And I will say this is not the counter, this is I equals to I plus 1. Right? So now I is 1. And you go up. Check the condition again. Is 1 less than 4? Yes. Go inside. Print x again. Increase I by 1. Now I is 2. And while go up. Check. I is 2 less than 4. Yes. Print x. And you keep going. Right? Till the time I is a 5. Right? And then you